Africa. Today is going to be discussing with you dual battery systems and also explain to you the general workings of it, as well as what I had previously installed in the vehicle, the issues that I picked up with it, as well as the current system. Obviously, two batteries, your starter battery, auxiliary battery. Starter battery comes with the vehicle. There's the vehicle that is used to start the vehicle and run the general or basic electronics that comes with the vehicle. Why the need for a auxiliary battery? So you want to go camping, you want to run fridges, you want to run auxiliary lights, you want to run inverter, whatever might be the case, you will need an auxiliary battery. Reason for that is you do not want your fridge and all of those things to be running off your starter battery or cranking battery, because if it drains this battery, you're going to be sitting with a problem, can't start the car, etc. So just for the sake of this discussion, I just want to make it clear, I am running normal flooded lead acid batteries in my vehicle. That is what I've been using. So I just want to quickly take you through the differences. I'm running my starter battery is a normal, like I said, normal cranking battery, flooded lead acid. My auxiliary battery is a normal deep cycle flooded lead acid battery. Now, this is a starter, this is a deep cycle. Just want to quickly take you through the differences between a starter and a deep cycle battery. So firstly, your starter battery was designed to supply a high amount of current for a short period, and that is to start the vehicle, or can even be used for winching or those type of applications. Your starter battery does not like to be deeply discharged. The reason for that is, from my understanding, is it's got a whole lot of thin plates, but a lot of them, so it increases the surface area. Therefore, it can basically give a lot of power quickly and also accept charge quickly, so it can be charged quick. The problem is with deeply discharging your starter battery, it will severely shorten the lifetime of the battery. So therefore, you don't really want to be running fridges or inverters of this battery. On your auxiliary battery, like I said, mine is a deep cycle. They are more suited to deep discharging. Now, deep discharging does not mean you can drain it to 0%. On a flooded lead acid battery, I would say around 50% of the capacity of the battery. It's got thicker plates but less, so there's less surface area, and therefore it's better designed to supply smaller currents over a longer period of time. The other problem is with it is that it does take slightly longer to charge. So the previous system I had done on my vehicle was by connecting these two batteries in parallel. Now, parallel is basically positive to positive, negative to negative. I did have an isolator in between to isolate the two batteries when the vehicle is not running. So that is what was how I had it set up previously. The problems that I picked up with this system, please bear in mind, these are two different types of batteries. So the application is different and the internals is different. So a starter battery, like I said, it accepts a large current and can charge quickly. Your alternator was designed around this battery. So your alternator will charge this battery up quickly after it giving a lot of current just after starting the vehicle. And that is how this whole system was designed. Now you're adding a different system to it, and the application and internals of this battery was not part of this design. So if you start the vehicle, your alternator will pick up the volts to 13.8 to 14.1. This is now on my personal vehicle. And this is more than sufficient to charge up your starter cranking battery. So the deep cycle battery, in my experience, this battery was always falling behind because it was being charged at these voltages. So somebody explained it to me this way. Voltage can be seen as the pressure to push current into a battery, put it that way. So if your voltage is too high, you're going to overcharge the battery, and if your voltage is too low, it's going to take forever to charge. With the deep cycles, because of the thicker plates, it does like to have a slightly higher voltage for it to efficiently accept current, and therefore this battery took forever to charge under these with these voltages. So the solution that I had is to install a DC to DC charger. So what the DC to DC charger does is it steps up the voltage in order for your battery to be able to accept current more efficiently.
Yeah, all right! Yeah!
Okay, so let me go and show you how this works on the vehicle. Alright. Okay, as you can see, this is now on the starter battery, stabilized at around 14.06 volts. Okay, let me show you what's happening at the back. Okay, on the rear battery it is sitting at 12.8 volts. This is with the C-Tech disconnected, so I'm just quickly going to connect the C-Tech. You should be seeing the alternator light coming on, realizing obviously there's a unit realizing that the vehicle is on. There we go, and then it will shortly give the charge, start charging the rear battery. There we go. Okay, so let's quickly jump to the volts. So the rear battery is currently being charged at 14.45 volts. 4245. And let's run to the front again. Now it's sitting on 14.02 volts. As this is not ideal for charging a deep cycle battery. It requires a slightly higher voltage. Alright guys, I'm going to try and explain to you as simple as I can how the system in my vehicle is currently wired up. Let's start off with the basics. The alternator that gives charge to the starter battery. So you've got the negative to negative, positive to positive. Alternators start charging the starter or cranking battery. Then from there you will have a positive wire running into the isolator. The reason why I put an isolator is instead of an isolator is just to basically stop current flowing through to the DC if I would like to switch it off. Alright, so you'll have a wire running from the starter battery into the isolator positive, out from the positive into the alternator input of the DC to DC charger. Okay? Then you will have a wire or a positive wire running out from the output directly into your auxiliary battery. negative, always sharing common negative, you will have a wire running from the negative all the way into the negative of the DC to DC charger. So now the DC to DC charger has positive and negative from the alternator or starter battery. Then from the DC to DC charger, you will also have a negative running into the auxiliary battery. So now you've got your positive and negative charging your deep cycle battery. Right. Then I just want to quickly talk about the solar input that goes into the DC to DC charger. Simple. You'll have a positive wire running into the solar input of the DC to DC charger. The negative I run directly from the solar panel directly into the deep cycle battery or auxiliary battery. Okay, so that is basically the dual battery system being charged by solar and the DC to DC charger. I did install I don't know what you want to call it, a battery box or a control unit. In this control unit you will have, I've got a volt amp meter. So please bear in mind the amp meter measures current flow over the negative circuit. Alright. This volt or amp meter tells me what the current voltage is on this battery. It also tells me how much current is flowing out of the auxiliary battery. Alright, so you will have negative flowing directly into the negative of this meter, and you will have a positive wire flowing directly into the positive side of it. So your auxiliary battery negative to negative, positive to positive on the volt amp meter. Then I've got a bus bar for the negative, so all your auxiliary appliances that you would like to draw from will basically be running off this, and this is a fuse box with individual fuses that will basically go to each individual auxiliary unit that you would like to run. If something goes wrong here, it will pop the fuses here. I will take you guys through fusing on the main circuitry and the importance of that once I'm done explaining this. So from your auxiliary battery, everything runs through the volt amp meter. So from the positive auxiliary battery to the positive of the volt amp meter, it's got a positive exit right into the main or into the fuse box, and then also the negative will run into the bus bar. Bus bar is just so you can connect numerous appliances or numerous auxiliary components to it. So from here you will have common negative running through to your lighting. You will have common negative running to your fridge. Now this is the fuse box, like I said. So if something goes wrong along the way, you will have one for lights, positive to positive. Let's say number 2 would be the fridge, so that will be running to your positive on the fridge. If any of these something goes wrong along the way from this fuse box to the auxiliary components, it will trip the fuses here, no problem. Let me take you through the fusing. I'm going to be using a green pen for the fusing. Very, very, very important on fusing or on using fuses. Anywhere where a positive cable is connected to a battery, fuse it as close to the battery as possible. So you'll get your alternator running in, that's fine, it's got its own fuse. So now you've got a cable running out to your DC to DC charger. You will fuse it as close as you possibly can to the battery. You will always fuse it on the positives, because negative is a common negative. You will fuse it on the positive. You've got the cable running through here into the DC to DC charger, then from the DC to DC charger out again to the deep cycle battery. You will fuse it again here. Then you've got a cable running out again from the auxiliary or deep cycle battery to your volt amp meter. Again, you will fuse it here. Because if you fuse it here and something goes wrong along the way here, there's nothing to stop the current from flowing. Always as close as possible to the battery. So these are your two batteries. You've got a positive going out from this battery. You fuse it as close to the battery as possible. Here you've got a cable coming in. You fuse it as close to the battery as possible. You've got a cable going out. You fuse it as close to the battery as possible. So there's two fuses here, one fuse here. I'm hoping that that makes sense, because any current from here will be stopped here. Any current from here to the DC charger will be stopped here. Any current to the DC to DC that's going to the DC to DC charger will be stopped here. Because you've got two batteries. Anywhere where a positive wire goes in or out of the battery, fuse it as close to the power source as possible. I'm hoping that that makes sense. Apologies. Your solar is also seen as a power input as a battery. Well, however, doesn't supply nearly as much power as any battery would. Always fuse it as close to the source as possible. So just a small fuse here should suffice. Good. Okay, so I just want to quickly explain to you battery capacities. So, like I said, in my vehicle, this is what I've got in my vehicle. Flooded lead acid batteries. My starter battery, you'll see on batteries they've got a AH rating. So mine is on the cranking or starter battery, it's a 90 AH amp hour rating, and on my deep cycle battery it's got a 105 amp hour rating. So what does this mean? Technically 90 amp hours is what this battery's current capacity is when fully charged. However, if you're going to drain 90 amp hours of the battery, you're not going to have a battery anymore. Similar with the 105 amp and 105 amp hour amps that it can produce for an hour. However, it doesn't work that way. So I just want to explain to you current draw on the different batteries. So your starter battery, in all essence, you don't actually really, when you start the vehicle and it takes a little bit, or it takes a lot of power, alternator quickly replenishes it. It's about 5, maybe 10% of the capacity of the battery, and it will quickly replenish it after a short drive. You can, however, probably discharge it to 10 to around 20%. I would not exceed that on a cranking battery, because you're going to severely shorten the lifespan of the battery. On the other hand, the deep cycles are designed to be discharged up to around 50%. Not ideal, but it can be discharged up to 50%. Alright. So if you're going to be taking, let's use 20%. 20% on a 90 amp hour battery, you have got 18 amps of usable power. Okay. On the 105 amp battery, you will have 52.5 amps available. Okay. So this is the differences between the current or capacities of the battery. All right. So now you'll be running a fridge. So my fridge is rather light on current. I'm not running a big fridge. It's going to depend on what size fridge you're running, and all of these are going to be variables. However, just to use an example, let's say for instance my fridge is drawing 4 amps per hour. Alright, so you're sitting with 4 amps per hour. Alright, your fridge wouldn't generally draw that amount of power continuously. It will take 4 amps, get up to temperature, and then switch off, and so forth. So it's not a continuous. You'll be looking out of a 12-hour cycle, probably about 6 hours of that it will be drawing 4 amps. But just for explanation purposes, let's say it's continuously drawing 4 amps an hour. All right. So on this one, you will have 4, 8, 12, 16. So it's 4.5 hours. 4.5 hours to basically deplete 18 amps out of this battery. On the deep cycle, on the same 4 amps per hour, 4 amps hour current draw, you will get around 13 hours of effective power out of this battery. And that is the reason why I prefer a deep cycle. I don't only draw a fridge from my auxiliary or deep cycle battery. I also got inverters to charge my camera gear. Also got auxiliary lighting. I've got a whole lot of. I'm charging 2 cameras, a drone, GoPros. It's endless. So therefore, the deep cycle battery. Alright, now just to bring things back in perspective. Alright, like I mentioned earlier, the DC to DC charger also has a solar input. Alright, so what now happens, the solar panel that I've got fitted to the back of onto the roof of the vehicle, in optimal conditions it will supply around 3 amps per hour. Alright, like I said, the fridge is drawing around 4 amps per hour. So this is not continuously. You get it running for an hour, switching off for half an hour, running again for an hour, switching off for half an hour, so forth. So now you will be, during obviously optimal conditions, you will be replenishing 3 amps an hour. So in all technicality, during the day, you will actually only be drawing from the battery 1 amp per hour. I've actually had situations where my solar panel actually will supply more power than the fridge is drawing, and that is obviously optimal. But it will all depend on current ambient temperatures and how cold you set your fridge. That is going to depend it. Normally I set my fridge to around 3 degrees and my freezer about -7. That's normally the settings that I've got. It also will depend on the size of the fridge that you have, but in my circumstances I've got a 50-liter fridge, and this is a situation. So you'll be looking at an average during the day of 1 amp per hour draw from a 52 amp hour available. You can be parked off for quite a few days. Let's say you go for one game drive within a 2 or 3 day period, the battery gets topped up as well. You can be parked off for a very long time without struggling to keep your deep cycle battery efficiently charged. Okay, so let me take you through my setup on my vehicle. Alright, so here's the starter battery. Here is the positive wire running to the auxiliary battery, and the negative running to the auxiliary battery. This is 16 square millimeter wire, and there is a 50 amp fuse. Okay, so let's run through to the back. These wires are running underneath the chassis, all the way underneath the chassis, and they come up onto the chassis in the back under the left rear wheel arch. So let's see if I can get focused here. This is my auxiliary battery fitted just behind the left rear wheel arch. That's the negative coming in from the C-Tech, and then you've got the positive on the far right coming in from the C-Tech. Then you've got the second going out through to all the auxiliary, and the third one is one that I can switch on the isolator to function 2. That directly connects the starter battery with the auxiliary battery if I need a jump start or something like that. If I accidentally run flat the front battery, leaving lights on or so forth, that should help. This is the wire coming from the roof, from the solar panel, and then all the rest of the wiring runs through here up into the battery control box. What do you want to call it? This box is constructed out of marine ply that I pulled over with carpet that I bought from my local carpet store. Apparently it's something that they use on boats. 80 millimeters thick by 450 millimeters by 350 millimeters. All right, guys. Then also, this is my, what do you call this? A high precision watt meter and power analyzer. You can buy this online. Just Google it and you will find it. This unit basically tells me the current draw from the rear battery, how many amps is drawing, as well as the current voltage on the rear battery. What I've going on at the back here, you get the wire coming from the starter battery. If you switch it to 1, it will supply power to the alternator function of the DC to DC charger, and it will do its voodoo, and this will go back out through to the auxiliary battery. This is the solar input coming directly from the solar panel. The negative of the solar panel is directly wired to the auxiliary battery. Alright, as you can currently see, power is being generated from the solar, not from the alternator, directly to the auxiliary battery. 600 watt Pearson wave inverter. This powers the first multi-plug where I can charge all my cameras and those other things from. The second multi-plug is direct AC input, which comes from here, the right rear of the bakkie or the vehicle. You had an AC source plug in here, and you've got normal AC power on this plug. This is the 12 volt inverted power. This is my fuse box. So number 1 is for lights, so if you switch on the lights and should something go wrong. Okay, let me just get this focus right here. Alright, so if the fuse blows or something goes wrong and the fuse blows, you'll at least know number one is lights, number two is the fridge, number three is the inverter, and number four to a monitor in the front so I can at least monitor my rear battery. Alright, so let's get to a camp, and I've got normal AC power available. I can just plug this in, and then this multi-plug will supply me with my normal AC power. Not sure if you can see down there, I've got a head-up plug at the bottom here. This is for the front battery, this is for the rear battery. So basically I plug in my charger in here. Here's my normal AC charger, so now I can independently charge the front battery. There we go. Alright, there we go. And this is just for my normal 12 volt auxiliary. If there's any lights or anything that you'd like to run off there, there we go. Okay guys, just a few things. If you are running cable underneath the vehicle, you can use cable ties to tie it to the chassis. However, I always prefer using trunking, as this will protect the cable from stone chips or stones hitting it and those type of things. Always put it in trunking. Then I want to take you guys through some crimping. So you want to be putting this onto the cable. If you don't have a proper crimping tool like this, rather go to somebody that can do it for you. Okay, so you've got your wire. You want to measure it around that same distance and then mark it. Birds are going ballistic. Yeah. Heat shrink. Try to get all the wires in there. Okay, so there you go. Now, and this, guys, is how you do a proper crimp. This thing is not going anywhere. Then you would slide your heat shrink up and let me see. This is how you do a proper crimp. Thanks very much for watching. My next video would be about my kitchen setup. It's going to be a shorter video, but I'll take you through that. Cheers guys. Now I want to go and make fire.